iterating over elements of a collection, that's the really useful part. It's really the concept rather than the actual method and the implementation and the syntax. So one reason for that is lots of languages allow you to do loops in different ways, and also in JavaScript there's a few different ways of doing of iterating over elements in a collection, and the loops that we're going to talk about today are
sorry to disturb you.
Yes.
I think they're just saying that Daniel and Hodan are stuck in the lobby. They're not allowed in for some reason.
Oh,
Yeah, that's why they haven't joined us.
is there a lobby?
Yeah, there's some sort of waiting lobby in order for you to allow us in.
But how did you all get in? I didn't let you in.
I don't know. It's Google.
We got a VIP pass.
Okay, so I think right. I think it's a different account, and I invited myself on my account, and I'm on. Okay, I'm gonna leave and join under a different account, and yeah, I'll be back.
That's the one I'm having problems with, to be honest. But I guess we'll discuss it now. How's yours?
I haven't started yet.
Man, dude, don't worry. Like that was me with HTML and CSS.
Hey, sorry, Daniel and Hodan. That was my fault, but also sort of your fault, because I think we were all using the wrong account. So the meeting was created by admissions at Coders in Hoods. Therefore, only that account can accept or can admit you entry. But I think if your email address was invited to the meeting, I don't think you need to be accepted. So I joined with my personal account rather than admissions, so I wasn't getting the notification to accept you. And also, I think you possibly joined with a different account. Daniel disagrees, so he's just left. I think that's what happened. Okay, sorry. Here he is. Okay. Right. We are talking about loops, and I was just saying it's really about the concepts. The style of loops that we're going to be talking about today are very useful, but the majority of the time I do the things that these loops are going to allow us to do. I actually use a sort of different method of doing it. So that I kind of tell people that I haven't written a for loop for years, which is not really true, especially in the last few months. I have. But there was a time where I kind of forgot how to write for loops because I just did it in other ways. So it's certainly about concepts, as always, really, because you can Google for syntax, but it's harder to Google for concepts. So bear that in mind when we're talking about loops. And loops are just for doing something multiple times. So if we want to do something more than once, we abstract that code into a function, so we can call that function multiple times. But if you remember on Tuesday, we had 6 lines of code that just called the same function. Loops are for if we want to call the same function 6 times or a number of times, and we don't want to repeat those lines of code. So if we want to execute a chunk of code multiple times, that is what we use a loop for. There are all sorts of different types. They're really ultimately all just for doing something multiple times. They don't really change, but exactly how they achieve that is a bit different. So we've got the for loop, the while loop, the for in, and the for of loop. There are more. Like I said, there are other ways of doing it. There are, the ways that I use, they're kind of iterators, array iterators. I would sort of not really associate them with loops as such, but there are more loops than these four, but these are absolutely the ones that you need to know. So a for loop, this is the kind of, I don't know, it's like the de facto loop. It is if someone asked you to write a loop in any language, you can probably assume that language supports for loops, and you write it in probably the same way in any language, and it is, yeah, it's kind of loops 101. It's definitely the first loop that you want to learn. So usually a for loop just does something a predefined number of times, and so it is for if you want to do something a number of times that you know. You can change it, but generally, if you know, okay, I've got 10 items here, so I want to do something 10 times, then you use a for loop. It's comprised of 4 parts. We have a counter, a condition, an increment, and then the code that we want to execute every time. The counter is usually a number that starts at 10. Now, I'm saying usually for all of these. The vast majority of the time, the counter is going to be a number that starts at 0. A relatively small number of times it might start at 1. An even smaller number of times it might be anything else. It could be a string, could be an object, could actually be anything. But the vast majority of the time it's going to be a number that starts at 0. Then we have a condition, and this is determining if we should keep running the loop. So the condition in this example, the number is less than 10. So our for loop is going to run until that condition is false. After every time we run our code, we then have an increment section, and that is going to, again in this example, increase the number by 1. It actually sorry yes.
Sam, are you displaying the slides?
Yeah. Am I not? I'm not.
No, I can't see it. I don't know about the others.
Don't think so.
You were just looking at my face, weren't you? That's a shame. Okay, let's go back. You missed so much good stuff. Loops, we're talking about for loops, while loops, for in, for of. Comprised of 4 parts: counter, condition, increment, code to execute. And now we're explaining those bits. So we've got a counter, usually a number that starts at 0. Condition, where in this case the number is less than 10. The increment, it's going to increase the number by 1. But we're referring to that as an increment. But that's only what it usually is used for. It's actually just a chunk of code that runs after every time our loop executes. So again, it can do whatever you want, but the vast majority of the time it is going to increase our counter by 1. Then finally we have the code that we want to execute every time. And this is the syntax for a for loop. So we have the keyword for, we then have parentheses that For it's kind of like a function. It's it's like a statement or an expression, but we have these brackets where we pass kind of arguments or three expressions. First one where we initialize, this runs once when the for loop starts, and this is where we create our counter. So we create a variable that we're going to use, call it number. We start at 0. Then it's separated by a semicolon. The next section, I've realised that the exclamation mark is outside of this string. What's that going to give us? That's weird. Is that going to work? I wonder what that's going to do. Anyway, the next section is the condition. Is what checks to see if the loop should continue running. So every time this code runs, it checks this. If this is still true, then it goes and runs the code again. After it's finished running the code, it runs this bit, and in this case, it is increasing number by 1. Therefore, we're going to start at 0. Every time we run, we're going to increase it by 1 until we get to number being equal or greater than 10, and in which case we stop running and we can kind of continue with the code that's underneath the for loop. That's the anatomy of a for loop. So most of the time you will want to do something for each element in an array. So it's not uncommon that you'll do something like this. You have a number somewhere and you just want to do something 10 times, you want to do something 50 times. It's not that uncommon. But that number is probably linked to an array. So it's the number of items in an array. The number we use to access elements in an array is called an index. So in this case, we're no longer calling it number, we're calling it index. So index starts at 0, let index equals 0, while index is less than array.length. Run this code and increase index by 1. So now, instead of just saying hello, whatever the number is, it's going to say hello, whatever the value inside the array at that particular index is. So we're now going to go to the code editor. Not there. There. No, not there. Oh, I didn't open it. There we go. And today, I think, in a surprising turn of events, I think I'm actually tired. It's not just this situation. I think I'm actually just tired. Okay, so 4. Now, we can. I mean, the data that we sort of created on Tuesday is probably a pretty good one to use. It's a nice example, but you might be sick of invented cities and what was it? Stations and usage stats. So does anyone have any suggestions for like an array of objects? That would be a nice thing. We could have like shoes. We could have the shoes that we're all currently wearing, and we can have the brand, the shoe size, the color, an array of materials on each one. That might be good, although it's lockdown, so no one wears shoes anymore. I don't know. We could. I think no one's saying anything, so I'm just going to nick the stuff from last week. Arrays, league. Okay, stations usage stats. Objects. This is what we want. Okay. So we've got our array of stations. There are 6 stations in this array. So we want to do something 6 times. So we write a for loop. We have for, we have the brackets, and then the curly brackets that are going to define the code that we want to execute every single time. 3 sections separated by semicolons. We start by creating a counter that is set to 0. We're using let here because we're increasing that counter. Even though we're not doing counter equals 1, counter equals 2, we're doing counter plus plus. Behind the scenes, JavaScript is doing counter equals counter plus 1. So it is reassigning counter to a new value. That's why we need to use let or var, but just use let. While counter is less than 6, so for every element in the array, we want to increase the counter every time. Console log stations counter dot name. There we go. We get all of the names of each station logged out. This is much easier than how we were doing it on Tuesday, because we're writing one line of code that does it 6 times. On Tuesday we had some other function, so you can I don't know, like increase stats, and we pass the station to some other function, and it just makes your code so much neater rather than having this line repeated 6 times. That is really not what you want to be doing. So if we just log out counter, we can see that it goes from 0 to 6. Now let's do some organization of our logs, counting up from 0. Counting up from 0, 0, 1, 2, 3, 4, 5. So remember, because we're starting at 0 and we're saying once this is false, then stop. So we start at 0, and then it increases to 1, increases to 2, 3, 4, 5. It then increases to 6, and then checks this and says, is counter less than 6? Well, no, because it's now equal to 6. So it then doesn't continue. It doesn't run again. So that's something that might sort of trip you up a little bit. So if you do want nice numbers, so you want nice numbers rather than computer numbers, you might want to start at 1. But here I've written 6 here, so again it's like nice numbers. I'm thinking, okay, 1 to 6, that is 6 numbers. I get 1, 2, 3, 4, 5, 6. But actually, because we're saying only do it while counter is less than 6, as soon as it's 6, it doesn't actually do it. So if you want sort of nice numbers that start at 1 and go to including the number that you've put in this second section, you need to do equals. So while the counter is less than or equal to 6, then run our code. So now we have counting up from 0, computer numbers 0 to 5, and now we have nice numbers 1 to 6. Of course, you can just do this and have counter plus 1, but sometimes this kind of, I don't know, makes it nicer and more readable. And if you use counter multiple times, you've got to have counter plus 1, counter plus 1, counter plus 1, which is not particularly nice. So bear that in mind. And again, every time you write a loop, just log out and see what the counter is, log out what the element in the array is, just always log everything out, just so you can be certain what those numbers are going to be. So, console log. I did work with someone once who did like log equals console.log, and then it meant he only had to write log, and I sort of thought it was a bit crazy, but the number of times I mistype stuff, I kind of understand it, but I wouldn't recommend it. It is a bit crazy. Okay, so now we want elements in the array. I know we just did this, but an important change when we're writing this now is actually the name of this variable. Although it'll work, so we'll start at 0, we'll go to stations.length, counter plus plus, stations counter, so it works. It is not a counter. In these two examples, we're just using it as a number that counts up. It is just a number. But in this example, we're not referring to this value as something that is sort of counting up and we're using it as a number. We are using it as an index. Therefore, you want to be explicit and you should write it as index. Very often you will see index shortened to I. So I do not like abbreviated variable names at all. It makes it incredibly impenetrable to someone else who's going to use your code tomorrow or next week, or even yourself tomorrow or next week. But I is really the only instance where abbreviated variable names is allowed. I is always short for index. And as I've said that I'm going to do my caveat thing again, there actually are kind of other examples, and I'll show those in a minute, but they sort of follow the same rule in a way. It's a little bit weird, but I'll show you in a second. Okay, so we got elements in an array. Always use I. Quite often you might want to store the element in a variable. Because we're writing it inside this block of code, it's block scoped, so we can kind of use it locally inside this block and then get rid of it after here. So we're just kind of storing this as element to use in the code in here. Again, if you're using this like 4 or 5 times, it's nicer to have element rather than stations I. And then going even further, element is like a generic term for an item in an array, but we know what this array is. It is an array of stations. Each element is actually a station, so you should name that thing as the singular version of the pluralized variable name that you're using for the array. It seems like it's not a big deal, but it genuinely is really important to name your variables correctly. Okay. Console log counting in other ways. So we have a for loop. We have some kind of value that starts at something. it's just going to be some random number. We have I is less than some other random number, and I minus minus doesn't actually have to be plus plus or minus minus. It could be I equals math.random, like literally a random number times a really big number, so we actually might eventually get there. This is weird, and I actually like, is this gonna break? So we start I at this big number. We say while I is less than this small number, run the code. But because I starts, yeah, that's interesting. So console log I is I. We don't get anything logging out. Counting in other ways doesn't have I is 5, 3, 4, 6, blah blah blah. Because this checks the first time as well. So I starts as a number that's greater than this number, therefore it never actually runs the code, because it's like, well, I've already passed the test, so I'm not going to run. If we flip this round, if while I is greater than this number, then run the code and set I to a random number. So I mean, it might just, yeah, if I disappear, it's because my computer's just exploded because I've done this stupid thing. But in theory, there's what, I is greater than that. I think it's not going to take too many. I reckon we're going to get it first time. I mean, there's a small chance that we'll end up in like a kind of infinite loop and everything's going to crash, but not first time. So it took loads of times. What am I thinking? Oh, loads of times. So I is greater than. Oh, right. While I is greater than that. So we actually wanted to be less than that, and so the chance of us getting that was that over that, which is probably quite a small. Let's do that in was a 0.003% chance of us getting that. So, you know, that, yeah, let's delete a few. There you go. It didn't take too long there. But anyway, this shows that it really doesn't have to be about just counting upwards by one every time. There are all sorts of things you can do, and it doesn't even have to be numbers, not numbers. Don't know what we can do really, but const person is an object where the name is just one letter, and while person dot name, I mean, the only thing I can think of is to do the length of the name, and while it's less than 10, then person dot name equals person dot name plus j console log person. There we go. We get a slightly weird thing, but it certainly, although ultimately we are just using a number here for the condition, it doesn't have to be. We can do this actually. We can do while is not that value, Ha. Oh, length. Yeah, excellent. I'm now checking. Oh, nice. NodeMon or NodeDemon got me out of that infinite loop. So there I was checking, is the length of this name equal to this string? It's never going to be equal to that. So that's why that completely freaked out. But here we're saying if the person's name isn't this sort of target name, then like add a J every time. Again, pretty stupid. It's not very likely that you're going to write a for loop to do this, but very occasionally you'll realize, oh, actually I could be a bit creative here and do something a bit different. Okay, I said there was another time where you can use an abbreviated thing, nested for loops. So also, I mean, I think as a beginner, it's better to write everything out yourself. It's actually, I know it sort of feels inefficient to not use the tools available, but I think it will benefit you to write everything out. But in VS Code, you can get it to write a for loop for you. So here you can see the vast majority of the time when you write a for loop, it's going to be because you want to use an index, iterate over every element in an array, access that element in the array and store it in a nicely named variable. So VS Code by default, when you tell it to generate a for loop, uses the name index, does it for array.length, creates a variable called element. So you can really tell that, I don't know, over 95% of the time you write for loops, it's going to be this use case. But we have stations, and then array is not defined. Okay, stations. This is going to be station. So now let's do another one. For let millions is 0, while millions is less than station dot usage millions plus equals 0.1 console log not reached capacity yet. Now reached capacity of station dot millions. Let's just do millions. Okay, so here we have a for loop and then a for loop inside it. We are accessing the station for in this for loop. We're then doing something with the usage stat on this station, and we kind of count up. Oh, we can talk about rounding errors. Rounding errors are fun. So you can see we are logging out every time we haven't reached capacity for that particular station, has not reached capacity, or let's do station.name has not reached capacity yet, so that'll be a bit nicer. Barking has not reached capacity yet. Angel, Earlsfield. So nested for loops are fairly common, really, and so if you have like an array of arrays, that is certainly a case where you'll have nested for loops. And so let's have array of arrays 5 5 5 6 7 8 whatever, bunch of numbers. So we have an array where the first element is an array and the second element is an array. So now we want our for loop. So we've got I which is the index of the array of arrays. Now this, we're going to be descriptive, and it's going to be an array of numbers. So each of these is going to be stored inside this variable every time we iterate. Now we want another for loop, and this is going to be a number and array of numbers length. And okay, it's written out index, but even if you had index, if you have index in the first one and then index in the second one, what, like index 2, weird. Using numbers in variable names is weird. If we shorten it to I, we've already used I, so we can't do that. We can't do that in this block anyway. So a pattern that you will often see is going through the alphabet. So J, it is a bit weird, but certainly in this case, you shorten index to I, and then if you are iterating over another array and you need the index of that array, you will go to J. I've probably seen L or JK. L, like seeing L kind of rings a bell, and just thinking this is not good. But it is a sort of pattern to go through the alphabet with these abbreviated variable names. Okay, array is not defined, array of numbers, fine. And lastly, a sort of, so I said that I don't usually write for loops these days, and there are occasions where I do, and those times are generally when I'm generating a grid, when I'm generating an array of arrays that represents a grid. So let's say grid is an array. We want it to kind of look like, I don't know, 1, 0, and then 0, 1, or we could do 3. We could do that. It's like noughts and crosses or something. So we're going to have a grid, and each array in the array is representing a row in the grid. So we're going to end up with that, and that is going to be contained in the parent grid array. So we have each row, which represents the y-axis on the grid, and each column, which represents the x-axis. So this value here is going to be x0 and y0, and this one is going to be x2 and y2. Okay, so I shall demonstrate. So we've got x, although actually y, sort of. So y is less than or 3 for x is less than 3. We go grid push 0, 1, 0, 1, something like that. Although we're not actually using x and y in here, so let's do that. X is x, y is y. Oh, right, no, I've done that wrong. So row is an array inside that loop, and then inside this loop, we push into row one object. That's why I was confused, or something didn't feel right. So for each y coordinate, we make a row, and then for each x coordinate, we push into that row. And then after we've done that, we push the row into the grid. So then console log the grid. Excellent, circular. That's really good. So JSON.stringify. Grid push grid. I'm an idiot. Okay, so maybe we don't need to stringify. So circular means there's like a reference to itself, so I should have sort of triggered. Okay, here we go. So now each object in this like grid, this array of arrays, is now telling us the reach capacity of undefined. What's that about? It's fun debugging. Station.millions. Idiot. Now each element in each array of arrays is telling us which coordinate it is. So this, because I make games, like this is pretty common. I will pretty regularly be constructing a grid that looks like this using two nested for loops that look like this. And the first 50 times I had to do this, it takes me ages, and eventually I've done this enough times that it kind of I just know how to do it. For example, at least when I think of a grid, I mean, no, it's not even just when it's like anyone. Coordinate systems start with x is first, x, y gives you the coordinates. So the first 50 times you write this, you'll write x first, and then you'll write y next. But now we've got like here, y is down there, and it sort of like works. It's not mathematically wrong, but when you log it out, it kind of looks wrong to the human eye. So going over the y axis first to generate each row just works. Okay, that's for loops, and really the sort of first chunk of trying to get to understand the concept of looping and doing things lots of times and using these values. And there's also sort of, okay, one other thing, maybe it's obvious, and again it's like incredibly unusual, but I don't know, modifying the counter. So let counter equal 1, so let's start at 0, console log counter, and in here, if counter is 3, then counter plus equals 10. Let's just do something a bit weird, but now we are actually inside the loop. We have some kind of condition, and it, after running this code, it runs it once. Is it less than 6? Yep. So run it again. It runs it again. Is it less than 6? Yeah. But the fourth time it runs it, counter is that someone? Do I need to let them in? Yes. Welcome back. The fourth time it runs it, I've sort of arbitrarily said, because the counter's 3, let's just add 10 to the counter. So the next time it runs the check, counter is no longer less than 6, so it doesn't run. Okay, that's it for loops. Any questions on for loops? Battery died, no warning. Yeah, my phone, like yesterday, I think, I had it plugged in to like a USB on my PC, and just wasn't charging. It was like at 8% all day or something. It was very weird. So I sort of thought I was going to have to buy a new phone. I hate technology, honestly. Nothing ever works. Any questions on for loops?
Just had a quick question, actually.
Mm-hmm.
You mentioned game development. I was wondering what would be a real-world example of using a nested for loop in a game environment, by any chance?
Agreed. That's why that was the example.
No, as in, so like, what would a grid represent in a game, for example? Like, what would it look like? Like, what would that be?
So,
like Tetris or something. I'm not sure.
I mean, yeah, that's a perfect example.
Right.
So, in your first thought when you think, like, okay, how do I make Tetris? You might think, okay, like as the thing is moving down, I want to like check a sort of collision if there's like a thing below it, and if there is, then like stop it moving, and if the row is, I don't know, colliding with others. It's just all an array of ones and zeros, and you just have a big kind of grid of this square is currently filled with a piece of a Tetris piece, or it's empty. That's all it needs to know. In which case, the next time it figures out if it should drop, just check if there's one at the y coordinate that is one greater than I currently am at, and if there is, then don't move it down. And then get that array, that row, if they're all one, then turn them all to zero, like remove them all. So actually lots of, like Snake is the same. Snake can be built and is just built on a sort of grid of ones and zeros. I can do some slight, I mean, it's not my own game, I built it for the company I work for, so it's not that exciting. But Pool 8, is this one going to work? Is this link going to work? It's a very old version, it's rubbish. Oh, it's rubbish. Anyway, this, yeah, I can get it. Pool 8. Okay, a slightly more recent version. Oh god. This is a grid of empty spaces, or like, oh god, I hate that sound. There is an empty space there, or there is a pocket there, or there is a wall there, or a cue ball, or another type of ball. So I can't be bothered to show you the tool that I made, but basically we remake games for that are sort of popular on phones, and we remake them for web sites like Facebook and stuff. We remake them for Facebook. And the original source, the original version that we got, does do it the first way I described. It's literally kind of just moving it up at a kind of constant rate, and it's like checking, is there something in front of me 60 times a second, and then it says, okay, yes, I've hit one, move this one. It's almost like physics or something, which is just insane when it's just a grid. So I built a sort of level editor because it's just a grid of squares, and it means it's super easy to like build a level editor that you can click on this square and it becomes a pocket, and then you click on this square and it becomes a two ball, and that's how you kind of lay out all the levels. So I like to simplify everything as much as possible, and there are lots of cases where in games it can be simplified massively.
Nice one, thank you.
No worries. Okay, let's move on to whatever's next. It's probably a while loop next. Yes. Now, where a for loop was used to execute something a known amount of times, except that last example where within the for loop you kind of change it. A while loop is used to execute code an unknown amount of time. It is all based on a condition, and while the condition is true, that code executes, and as soon as it becomes false, it won't execute, and the interpreter will move on to the next line underneath the while loop. So that's why it's called while. It's just saying, while this is true, then do this. Now, in this case, it can just be used in pretty much the same way as a for loop. So we have, remember the sort of 4 parts of a for loop. We have initializing the counter, we have incrementing the counter, we have checking the condition if it should continue running, and we have the code to run. We have this here. So if you're going to do this, if you're just going to have a number that counts to 10, you should use a for loop. It's literally designed for that. It has all the parts for that. Whereas a while loop, you sort of have to use a while loop, but also use a variable outside the loop and increment, make sure you increment it yourself inside the code block. So although it is possible, this is not a great use case for a while loop. But it is possible. So we create a number, create a variable called number. While it's less than 10, increase it. So as soon as it gets to 10, it's gonna say, okay, this is now false, and I'm going to move on to the next line. While, so what's changed here? I've flipped that. While number is greater than 0, number plus plus, and the number is starting at 1. So let's think about what happens the first time. While number is greater than 0, number, which is 1, is greater than 0, so that's true. So while true, execute this code. Number plus plus, so that's going to increase number to 2. So let's run it again. While 2 is greater than 0, which is true, so therefore it's going to run. And 3 and 4 and 5 and 6, infinitely. Now, I hate while loops because no matter how many times you use them, no matter how many times, no matter how simple it is, I always get stuck in an infinite loop. It's just one of those things. I always say this to Vasil, and he says the same thing. So I think it's not just me. I think I do have a bit of an issue with it, and the more it happens, the more I get like a complex. But it is useful if it's really a kind of unknown quantity. If you're kind of waiting for something to happen, or again, in my old job, we used to like generate sort of lottery tickets essentially, and if we wanted to just generate 1,000 tickets, but a ticket had to be like validated and pass a bunch of checks, we'd like generate a ticket, and then if it passes the tests, we'd add it to our array of tickets. But if it doesn't pass the test, we won't add it to the array of tickets. So it's like, while the number of tickets is less than 1,000, just keep trying. You might be rejecting every other ticket, but just keep going until we have 1,000. So that's certainly a use case for a while loop. And as always, if you mess with the tests and suddenly nothing passes, you will never get to 1,000, and therefore you're stuck in an infinite loop. So that's it. There's not a huge amount to the while loop. We're gonna do some, and fingers crossed, don't get stuck in an infinite loop. Although I probably will. Okay, so here, while true, console log infinite. I mean, NodeMon seemed to like work nicely, so I'll save and it'll do it, and then I'll try to comment it out or change this to false or something. I'll try to undo it quickly so everything doesn't die. So false, that typo. Wow, NodeMon is really good at stopping that. in a browser, if you get stuck in a while loop, you genuinely, I mean, I don't really want to demonstrate because I can't be bothered, but you have to go to More Tools, Task Manager. Chrome has its own inbuilt Task Manager. You have to find the tab that is in the loop and then end the process. And I was debugging some issue the other day, and I had to do that like 50 times. It was very embarrassing. But also, this like VS Code highlights code that isn't used. So if you have a variable that you create, then you do something with it, function. Okay, why is VS Code not? Okay, fine. VS Code, I thought it would sort of fade that out, but it's faded this out. Maybe you can't see over the stream, but VS Code is reading this and it's saying while false, well, that's just never going to run. So it kind of fades this out to let you know that you have unreachable code. But let's do some counting. I plus plus let I 0 and we have got there. One difference is outside of the loop we now have access to that counter, whereas with a for loop the counter only exists inside the block. So if I don't know, while I is less than math dot random times 50, or like 50 plus math random times 50. So here it's like count up a kind of unknown number of times, count up a number of times between 50 and 100. Although actually that's going to change every single time, because with the while loop it runs this condition after every single time the code executes. So we're going to result in like a random number every time it runs the check. So that's not a great example of sort of how to do it, but we should at least get a sort of random. It'll probably be low 50s, I'm going to say. Yeah, 67, 58, 64. Like you might think, oh, a random number between 50 and 100, the average might be 75, might be somewhere kind of in the middle. But because we're doing this check every time, once it gets to 50, it's like checking, it's generating a new number between 50 and 100, and then if that's false, it generates a new number between 50 and 100. So like the likelihood of it kind of being low enough that you've passed it is increasing. So let's change that a little bit. Target is this number, so while I is less than target, 64, 87, see we're getting a bigger spread, we're getting 98, we're getting certainly a much more, oh we got 100, how exciting. We're getting a wider spread. Okay, so that's like a while loop. That's obviously this is a very simplistic example, but it's a relatively kind of good example of the sort of logic that might happen with a while loop. Although actually it's probably more likely that this would be plus equals math random, because here inside the loop is the sort of unknown thing. Yeah, if we have a fixed target and we just want to do that a number of times, again we can just use a for loop. So now it takes longer, and now we get a sort of decimal place. So while, let me think of like a real use case for a while loop that I have. I mean, let's build that lottery ticket generator. So function generate ticket, return 1 2 3 4 5 and math.random times 10. That's how it works, sort of. Now we have valid tickets is an array, while valid tickets dot length is less than 1000. Then new ticket is generate ticket, and valid tickets dot push new ticket. So now it's gonna work, but it's there's no validation going on. So again, this exactly how we've done it here could just be a for loop. We are just doing it 1,000 times. But so now we want to if validate ticket, passing in new ticket. If that passes, then only then push it in. And validate ticket could be I don't know. I'm just gonna. Okay, so it takes the ticket. That's random between 0 and 10. So return ticket. Ticket length minus 1 is less than 4. So the tickets are only going to be valid when the last element in the array of ticket numbers is less than 4. Pretty weird, but it's not too unusual. So now we're going to have valid tickets dot length, which should just be 1,000. There we go. We get 1,000. We should get 1,000 every time. Now, if we want to see the number of times this loop has run, we can have like attempts start at 0. At the end of this loop, we can increase attempts, and we can log out the number of attempts. So that time we so therefore, I don't know, you could say something. You could say 1,000 successful tickets, 1,503 unsuccessful tickets. Log it again. 2,34923. So it's like roughly the same, but that is absolutely a use case for using a while loop when you have some kind of unknown quantity in here, but then you accidentally like less than -4, and then suddenly you're stuck in an infinite loop. So do watch out for infinite loops. They're very easy to get stuck into. To be honest, I think this sort of thing is really the only use case that I can think of. I know there was a while loop in a project that I worked on last week. Like I said, I kept getting stuck. I didn't write it, and I don't think I would have written it as a while loop, but I was fixing a bug, and so I sort of kept it in there. But I can't remember what it was. I think it was something pretty much the same as this. It was like, while we don't have enough things pick a new thing, and then if we've already picked that thing, then we don't want to keep that thing because we don't want any duplicates. That was pretty much the same thing, and it's very similar to this. So I don't think there's any point in kind of building that example now. Maybe if there's time, we can do it at the end. So, any questions? AJ says a while loop could be used for password logins. What, you mean to guess someone's password?
No, or like for example, if someone keeps inputting it, and actually I thought about it, probably a for loop is better, but not for guessing passwords, but just like while something is not true, they won't let you in, if that makes sense.
Not really.
Right.
So the problem with a while loop and getting stuck in an infinite loop and the fact that you can get stuck is because it is synchronous. Now,
right.
Next week, or actually probably after that, probably module 2, we talk about synchronous and asynchronous code much more, but it's blocking. So
right.
what we could do, so valid tickets length, console log start ticket generation, and then end ticket generation. So you can't really see any sort of delay, but if we whack this up, you can see it hangs. It said start ticket generation. Have I done it too much? And it hasn't yet generated enough tickets. The code has stopped. It is here. It is only doing this. So you can't. I mean, are you still there? Like, has my computer just completely frozen? I think it's fine. I think NodeMon is handling it. But so a while loop is if you want to do a lot of things like at the same time, whereas someone will type their password in, you'll have a variable somewhere called attempts. Let pass login attempts equals 0, and then you'll have a function login. I don't know, if password is incorrect, login attempts plus. Like it's separate to a while loop. You're just there. You won't be looping in that case. Okay, we finally did it. It didn't like it. That was too many. But you can, yeah, okay. Start ticket. Let's do it gradually. Okay, there we go. I'm going to do one more 0. There, it's hanging at start ticket generation. In like 10 seconds or something, it should finish. So it's blocking, it's code blocking, and it's generally something you want to kind of avoid. Yeah, in a few weeks we talk about asynchronous code and how we can deal with that. But yeah, you wouldn't really use a loop in that case, unless you actually were trying to guess someone's password. But again, that's not worth it. The alphabet is too complicated. That you would be stuck for a very long time. That's not how hackers work. Okay, looks like there's no more questions. for in. Now, I have used the term iteration a few times, and we are iterating over all of the elements in an array. That's what we were doing with our for loops, for index being less than array.length, like do something and then increase it, so iterate over every element in an array. That's such a common thing that JavaScript gives us an even easier way to do that. So we have a for in loop, and for all the keys in an object, do something. So remember that an array is an object. It's just an object where the keys are numbers, and they start at 0 and they increase by 1. But an array is an object. So for in can be used for arrays and objects. It takes all of those keys, and in an array it's going to be indexes, in an object it's going to be strings, and we execute some code for every element in that collection. So we have an object here with 2 keys. We have name and age. So for key in person, for every key in this object, give me access to it in this variable called key, and therefore I can log out. I can say key and then the value using our square brackets, and Daniel, that's a hint to how you could tackle that exercise. So square brackets, we're dynamically accessing a value based on whatever that key is. So we're going to log out name, Sam, age, 29. And hopefully there's an array. Yes, there is. We've got one array with 3 elements in it. Sizes, for key in sizes. This will, I'll ask you, what will this log out? So where the previous one we had name, Sam, age 29, what is this going to log out? It's not a trick question.
Is it index?
Yes, the indexes, exactly. So the keys on an array are the indexes. So what are the indexes going to be of these 3 elements?
So 0, 1, 2.
Exactly. So the key is going to be 0, then it's going to be 1, then it's going to be 2, and therefore we're just getting sizes square brackets 0, which is the value s square, sizes square brackets m, sizes square brackets 1, which is the value m, and so on. So in an object we get the keys, which are strings. In an array we get the keys, which are indexes. Okay, let's play around with a for in. Oh look, it even generated a report to tell me how stupid I am by letting it run out of memory. So for in.js. Okay, let's do this. Okay, let's do some interesting stuff. Okay, so again, VS Code does generate this for you. Now, there's a bit more sort of boilerplate to this, and this has own property. Now, it's a slightly weird one because you're thinking like, well, if the key is on the object, of course it's going to have the property. So why do I need to check for that? And yeah, I think there's some value in that. This would certainly not be like what I write by default, because I'm just assuming if the key is on the object, then why are you giving it to me? But it could have a key, but the value could be undefined. The key could be there because it is defined on the sort of prototype of the object, and prototypes, we'll talk about that later on in the course, but they're basically the sort of template versions of objects. So every object actually kind of belongs to this sort of template version of an object, and so it could be defined on that template version, on the prototype version, but not actually on this version. Anyway, I think it's overcomplicating it slightly, so I'm going to remove that. But we have for key in object, and I want to access the element, they're calling it, but I'm referring to it as a value, even though if we're working with an array, should really be called an element. But because we're just using this sort of generic term object, it might not be an element, might just be a value. So we are going to, what we're going to do, log out the key and the value, and we're going to do the same for teams and points. So our keys are 0 to 5, and our values are the elements in the array. So now let's do an object. Let's have an object which is a Pokemon are good. I kind of hate the fact that I always go to Pokemon, but they have quite a lot of stats. So ID is 5, name is Pikachu, type is electric, don't really know anything else. A stats is going to be an array of stats, stat. There is a Pokemon API, and I'm kind of basing it off this, but HP, and then the value is like 100, I don't know, something like that. So we now have an object. For in, let's ignore that. For each key in our object, which in this case is Pokemon, then access the value on there, and we want to log out key and the value. So here, key ID, value, 5, name, type, stats. So if you want to do something for every key value pair on an object, a for in is really useful. Really, I mean, you'll see in 5 minutes like another type of loop very similar to this, and I don't know. Again, I don't really use either of them that often. If I were to, I actually should. I think a for in loop is probably better than how I would do it. And maybe I'll show you how I would do it in a second. But it's pretty good. I actually think a for in is probably better than how I do it, and it's quite easy to understand. So for loops, think back to an hour ago or whatever it is. For loops are, of all of these ones, I think for and while are certainly the ones that you actually should learn and probably use more often than for in and for of, because they are much more language agnostic. They exist in every language that I know of, and whereas for in and for of, they're a bit more like specific to JavaScript, and they're pretty useful, but at this point it's better for you to like learn the long way round, and the way that can be easily transferable, because you kind of want to label yourself as a sort of full stack developer, or a front end, or like a slightly genericized version of the term, rather than a JavaScript developer, because you might be able to apply for a job where they use Ruby and Rust or like other languages. It's not that likely that you'd get it, but it is much more transferable. Things like for loops and while loops are a bit more transferable than for of and for in. And there I've just mentioned for of, so I think we'll go straight to for of. Oh, look, I even planned that was how I was going to do it, because there's no slide for questions on for in, so we just go straight into for of, either an accident or planned. So where for in iterates over keys, for of iterates over values. Now, for in, like generally when people talk about these two, people sort of say, oh, for in is for objects and for of is for arrays. We just showed that it's not necessarily true, because an array is an object, but you maybe don't really care about the index in the array, but you want to do something with the values, the elements in the array. So for of just gives you the values, and it doesn't give you the index that you then have to go in and get the element, it just gives you the element. So here, whereas if we look at here, we have to do sizes key to access the element at that position in the array. Here, value is just going to be the value. We're just going to iterate over SML, and we just get access to the value, the elements, immediately. So it's not really true, but for in, generally you're going to use that with objects, and for of, generally you're going to use that for arrays. So let's for of JS. For we've got stations. Let's use stations again. So again, for of iterator of object. I don't like those terms. The vast majority of the time, it's going to be element of array, or I might actually prefer, if we're going to go with object, I might prefer value of object. But in this case, certainly it should be station of stations. You want to name it nicely. Console log station name. Nope, wrong one. So here we have station, Whitstable, station Romford, etc. So it's very similar to your for in. We're doing pretty much the same thing as our for loop. We're doing a very similar thing to one of the while loops we've written. For of and for in are they're not that modern, but they're kind of recent additions to JavaScript. Oh, excuse me. I went for quite a while without yawning. So they're useful. They're everything that's been added to JavaScript in the last 6 years. It's all about improving the developer experience, the quality of life. Quality of life is a phrase that comes up quite a lot in development. You want to improve the quality of life of users as well as like other developers. So that's 4 of. I mean, there's not really much to it. I suppose we can look at the equivalent. So 4 of value of stations 0. I mean, or if we want to go crazy, we could do station, a nested 4 of. What's happened here? I want to format it, please. Okay. Console log value station. So we don't get the key. Station is not iterable. Really? Station, value of station. Can 4 of not be used on objects? So I've said here, this is useful when dealing with arrays, but is it true for of over iterable objects, including built-in string array-like objects, and user-defined iterables? Okay, so not objects. That's interesting. So it'll work on a string because a string is actually pretty much just an array of characters. A map is pretty similar to an array. A set is similar to an array. Huh. I did not realise that. Again, like I said, these things I don't actually use fairly often. Oh, I said I would show you that. So, any questions on 4 in or 4 of before I show you whatever I said I would show you, but I can't quite remember. Any questions on loops or anything before? What time is it? Before we just mess about. Mushtaq says, shall we say we should forget 4 in and 4 of from now on? Yeah, I mean, I think so, because I mean, you're learning at a relatively fast pace. It seems sort of simplistic, but it's gonna like take up space that something else could be used for. And for loops and while loops, they're much more generic versions of loops, so they'll be much more useful in the future. And even then, in a couple of weeks, you're gonna learn sort of how I do this stuff most of the time. So arrays have kind of built-in functions that allow us to do this and to do the types of things that we want to do regularly. Actually, I'll do some of that as well. I'll do some of that. I'll write a filter function, or I'll write a reject function, so it's a bit different from filter. Anyway, oh no, sort of, yeah. Anyway, so if there are no other questions, then I'll just mess about and show you the thing that I said I would show you, and then just build a sort of reject function and stuff. Okay, Mushtaq says cool. Okay, so what was it? It was 4 in. Okay, so I said 4 in actually might be better than what I do. I think 4 in is certainly going to be better than the way I show you now, but what I'm going to show you is actually sort of only half of what I what I do. So we're going to start by getting an array of the keys. So we have the global object called object. There is a function on that class called object called keys. We can pass it an object, so we're going to pass it Pokemon, and we log out this array of keys, and we're doing the wrong file, and we see here we get an array of these keys, of strings, ID, name, type, stats. So this is the sort of starting point of not using these kind of for loops. Like I just said, arrays actually have a bunch of built-in ways of kind of doing this sort of thing. So what I would do, I am like converting my object to an array, and then I'm going to iterate over the array. Now this bit, I'm going to do it using a for loop because of this is what we're currently learning. But actually, if I was doing this, I would just use one of those inbuilt methods on the array. So now we have I, we have Pokemon I, we have value, and actually I is now, oh no, I is good, but Pokemon I keys, it's going to be keys, key, that's going to be key, and then if we want the value, we get Pokemon, so value is Pokemon key. So this certainly, you can see that like these two ways are certainly not like for in is certainly better in this case if we're doing it like this. But once you add on the array methods, it does make things easier. So one of those array methods is filter, and we'll talk about that later on, but very often one thing you want to do is take an array, and based on some sort of condition you want to like create a new array that contains only some of those values. So you want to like reject some elements and you want to keep other elements based on some condition that you make up. So let's array, I don't want to call it filter because it's like too easy for you to cheat in an exercise in a few weeks by looking at this code. I want to do reject. So Ruby has a reject method, which is like the opposite of filter. So array reject. Okay, so we're going to have a bunch of ages. We're going to have 3, 19, 4, 22, 267, 24, 55, and 80, and 93. I think my gran died yesterday, and she was 93, I think, or 94. So I'll chuck in her age as well. So we are going to have a function, a reject function, that is going to take an array of numbers and a minimum and a maximum, and we want to return a new array that includes only the numbers that are within this minimum and maximum range. So we say numbers which match is a new array. We're going to return numbers which match, and in between we're going to populate numbers with match. We're going to do something. So for, what can we do? For of, yeah, why not? So for number of array of numbers if number is greater than minimum and number is less than maximum, then numbers which match push number. We only want to include in this array numbers which pass these two conditions which combine to make one condition. So console log reject ages. We only want ages between the age of 18 and 60 or something, I don't know. So now we get an array of 19, 24 and 55. We haven't changed the original array, console log ages. That still contains all of the ages. So we're creating a new array. We're iterating over our original array. We've got some condition and we're kind of rejecting or accepting numbers based on this condition. So this sort of thing you do very often. You only want to do something with some of the elements in an array, and therefore arrays have kind of built-in functions to help us with this. And yeah, so that's quite a useful exercise to write functions like this. It really helps you understand arrays and conditions and actually the functions later on. So later on you're going to be using the filter function that's built into an array, but even figuring out how to use that is quite complicated. But if you write your own version of the filter function, which is an exercise, it's an exercise that I think with the previous cohort we kind of said it's not a mandatory exercise because it was too difficult, but I keep saying how good an exercise it is. When I first did that exercise, I learned loads by doing it. It just really reinforces your understanding of functions that you use, I don't know, dozens of times a day. So you can look forward to that in a few weeks. 49, I've still got 10 minutes left. Is there anything else I said that I would do but I've forgotten? Or have you got any questions?
Speak briefly about dot sign. I think you were mentioning that you
would mention
that briefly.
Yeah. Oh, and Daniel, I said there was a hint to your exercise, but I can talk about it now if you want. So yeah, AJ wants to know about object assign. Object assign, and in fact, this just came up. Object assign versus spread. Now, that is the reason why I don't really use object assign, because if I'm going to do the thing, I'm going to use spread. I'm going to use the spread operator, which is covered. It's like a relatively new feature of JavaScript. It's like a neat new thing, and so we talk about it in a lesson where we like go over a bunch of neat, cool, modern JavaScript stuff. But object assign, it's basically for assigning key value pairs that exist on one object to another object. So we have this, every time I use this example, and it's kind of formatted weirdly so it's hard to read, but I don't find this example particularly easy to understand. But we have a target object and we have a source object. So the target object has A and B. The source object has B and C. So we call object assign here, and we pass the target object as the first argument and the source object as the second argument. So this is like the sort of base object, and then any key value pairs that exist on the source object get added onto the target object. So target, it mutates it. Another reason why I don't use it, that's stupid. Expected output object. Return target. Copies all enumerable own methods from one or more source objects to a target object. I mean, that sort of explains why it's called target object. As I was explaining it, I was like, it's not really a target. But so it actually changes this object. I'd forgotten that. So it actually is adding the key value pairs to that target object, and it returns a kind of new sort of a copy. Here it says it returns the target object, so it actually seems like it returns the same original object. So we can try that out. Console log target equals return target. It is true. So that is actually, so storing it in this return target variable is a bit unnecessary because you just have access to the exact same object up there in target because it's been mutated, that original one. Okay, so the most common use case, at least for me, the most common use case for object assign is to make a copy of an object. So based on all of that stuff, we have a target object and we have a source object. All of the key value pairs on the source object get applied and added to the target object. Therefore, let's do source is this, and oh, that's why. That's weird. Okay, so now copy of source. So we want to assign all the key value pairs that exist on our source object onto this object, which is a new object. So copy of source is now the exact same thing as the source object, but where previously I did is assigned target the same as the original target object, and it was just the exact same object. Here it is this object. We have our source object and this object that's gone in here and then come out here with all of those key value pairs assigned. So we run it and that ends up being false. They are now different objects. We have created a copy. So that is a pretty common use case. And then a slightly different one, like adjusted source is object.assign. If we want mostly a copy, but actually we want on this one C to be 10, then you would do this. So adjusted source. So you'd oh no, that's not true actually, is it? Because it's going to overwrite it. Again, stupid. This is why I do. Oh yeah, okay. So this syntax on the documentation means that there can be any number of arguments. So if you do want an adjusted source that has all the key value pairs, but where C is 10, in this case, everything that's further right is going to overwrite whatever's on the left. So the thing on the left we want to be empty, then we apply source, then we apply a new object that has C being 10, and now we'll get a new object, all the key value pairs of source, but also all the key value pairs of this, and we can have an unlimited number of objects being passed through there. Yeah, so object design is pretty useful, but certainly these days I tend to use the spread operator. Oh, that's quite nice to know. It uses getters and setters, which we'll talk about in several weeks. When did object assign get invented? Chrome 45, Internet Explorer, no. So actually it's fairly recent. Spread, I think, is more recent, but anyway. Daniel says yes. I can't remember what that was to. Was that, do you want me to, was that, did it help, or do you want me to talk about it?
Yeah, could you please talk about it?
Okay. So, I don't want to do exactly the same thing, but I am basically going to do exactly the same thing. So for okay, I guess keys.js station is that object node mon keys, and we want to get station.name or station.usage. So there we get the value for station name and the value for station usage. What's another way that we can get access to a value on an object is by using square brackets. So station name, station usage is exactly the same. Now we can do the same thing, but we have key, let key equal name, and then log it out, and then assign it again, let key equal usage, and then it's exactly the same. So get key on object key, return object key, console log, get key on the station, passing in the string name. So here is going to be name, that's going to be station, we're just going to be doing this, we're going to be doing this, which ultimately just does this, or usage. So we're calling the same function and we're passing in an argument that changes both times. So that is a slightly more dynamic version of your exercise, but here, like station info, we just have the key and the station is kind of hard coded. So console log station info name and usage gives us Whitstable and 1.2. Does that help, Daniel?
Yeah, you're nudging me in the right direction.
Yeah. I don't want to sort of just do it for you, but
yeah.
That if you look over that, if you really just try to think about what is being asked, and it's about either or. I think at this point in your career, someone, I can't remember who, AJ maybe said, oh, you need an if else, like if the key is mother, then return child.mother, else if it's father, return child.father. And you kind of just can't help but think in that sort of way, but eventually you'll come round to realizing that there's a bunch of different ways of doing the same thing that just allows for much more dynamic code. it's basically laziness. Developers are lazy, and if you've supported mother and father, but then your product owner says, oh, we actually need uncle as well, if you've written it in the way that just accepts whatever, and it returns whatever, then you can just be like, yeah, done, that'll already work. You just type in uncle and it'll work. Whereas if you've done it like if it's mother, then you have to go in and change it. So you kind of just get a skill for sort of planning ahead to ultimately be lazy, which comes with years of practice.
Where I was even tripping up was the return, because once you return something, that's the end of the block. You can't even
Yeah.
you can't even add anything else.
Yeah, so that's true. So an early return. So here, station info key, like if station key is undefined, we can return early. We can use brackets return not found. So very often I will use this early return like to my benefit. So what you might do now is like else return station key, but actually it seems like a stupid thing, but like as soon as code is indented by one more set of spaces, it's just harder to read. But because of early return, we just don't need the else. If this is true, we've returned and we won't continue down here. So the early return absolutely trips you up at the beginning, but actually it's a really nice feature. Not all languages do that, but it's really nice.
Cool. Cheers. Thanks, Sam.
No worries. I think I've waffled enough. Cool. Thank you very much, everyone. I'll get all of this uploaded. I'll deploy stuff on loops. Yeah, see you next week. You're with Vasil, I think. What are you doing next week? That's me. You are. How do I do it? Oh, up there. Functions and building a CLI. Oh, I see. Right. So it's the last week in the module. So that last session is kind of everything coming together, building a CLI, but don't leave it until after that session to do your project. I think start now. Really, you have everything you need to kind of do a decent amount of it, and it might be a struggle, but it's probably still going to be a struggle after this session as well. So the sooner you start that struggle, the better. So don't leave it till the last minute. Okay, that's it from me. Thank you very much, everyone. See you in a couple of weeks for module 2.
Thank you, Sam.
See you.
Everybody. Bye-bye.